Alright, let's see what we got here. Count square submatrices with all ones. Given an m by n matrix with ones and zeros, return how many square submatrices have all ones. So I've done this one before at some point. Input matrix equals this. So if it's a square submatrix, then all the ones could be a 1 by 1 square. So there's 3, 7, 10 ones. And then 2 by 2s, there's 1, 2, 3, 4. And then there's 1 3 by 3. Okay, and then here there's 1, 2, 3, 4, 5, 6, 1 square matrix. 1 2 by 2, and that's it. 7. Okay. So you can start by counting. So I think obviously you don't want to do like a quadratic solution here. Actually, I'm not even sure how you do a quadratic solution. So what would it mean for it to be a square that's bigger than a 1 by 1? So 2 by 2 matrix, in order for it to be a square 2 by 2 matrix, it would have to expand on a, or what does it mean? So if you have a 2 by 2 matrix that you know is a square, then if all the sides of it are ones and the extra diagonal corner is a 1, then it's now a 3 by 3 matrix of ones. So if you kind of go diagonally, and verify that everything on the right and bottom of a square matrix in addition to the next diagonal is ones, that thing is a square. I feel like you should be able to do this in one pass, I think. Can you do it in one pass? I guess if you were to keep a counter of for every square, the number of consecutive ones above it and the number of consecutive ones to the left of it. Would that work? Number of consecutive ones above it, number of consecutive ones to the right of it. And if you're on a particular square where the number of consecutive ones above it and to the right of it is a certain number. So if it's 2 and 2, so let's say we're at the square, the bottom rightmost square, the number consecutive above is 2, the number consecutive to the right of it is, or left of it is 2. And because it's a 1 as well, then it can count as a 3 by 3 and as a 2 by 2 and a 1 by 1. So you take the minimum of the consecutive ones above it and consecutive ones to the left of it. If its minimum is 0, then this means that the value itself only is going to satisfy only going to satisfy itself as a square, as a square submatrix with ones. So for every position, the consecutive ones above it and the consecutive ones to the left of it needs to be tracked. So here for any square, if track the number of consecutive ones to the left and right of a square, of that square. So if a square, so for example, if a square, maybe I should say position. If a position has 2 ones above it and 2 ones to the left, and it has 1 as well at that position, then a 3x3 can be formed where that position is the bottom right. So like if I have, oh shit, then I need to fill in the stuff inside as well, right? So if I have, say, x, there's a 1 here, there's a 1 here, and let's say there's a k here. So k, assuming this is a 2x2 here of ones. Assuming it's a 2x2 of ones. Okay, assuming also that the inside portion is a subsquare of ones. I can probably keep track of another array that is the largest subsquare at a particular position, at a particular rightmost position, bottom rightmost position. This doesn't seem very elegant. Can I do this in one pass? So I just go everything on the first row. In the first row, all the positions, all the ones there can be formed a 1x1. Everything there can be formed at 1x1. And track the number of consecutives. Okay. Okay, so let's go ahead and try to do something here. So is there a more simpler way of doing this than what I'm currently thinking of? 1, 1, 1, 1. The number consecutive. Whatever. consecutive above is going to be, okay, let's say rows and columns is the length of the matrix, is the number of rows. Length of the matrix at index 0 or row 0 is columns. Consecutive above is going to be a 2D matrix that also is the same. I think it's the same size. So say it's currently going to be 0. So I want it to be the same size. It's 0 times the number of columns for every row. Okay, in the range of rows. Just verify that this is correct sizing of the 2D matrix. So, yeah, okay, I think that is correct. And let's say consecutive to the left is the same. Okay. And then I think I want one more. I think largest, biggest subsquare, biggest sub is going to be also 0 for every position. This might be, I might need to make this one bigger actually. I think I might want this to be one extra column and one extra row. Because at any position, I think I need to index something that is slightly to the left or above it. So it has to be kind of, has to go kind of out of bounds or wrap around. Yeah. So let's say the answers equal 0 for every position in the matrix. So for every row in the range of rows, this is row index, and for every column index in the range of columns, if the value is whatever is at the position in the matrix, if the value is 0, then everything's pretty simple. If the value is 0, then I don't think I have to worry about anything. I might just, I think I might only need to continue. Yeah, because a value of 0 breaks all streaks, consecutive streaks of 1s, and also means that that position can't have a subsquare of 0 or subsquare of 1s. And then if the value is 1, then I need to figure out how many subsquares it can maximally have and how much it changes the consecutive ones. So here this is 1s. So here I'm going to increment consecutive streaks. So gosh, I think I might actually want to be able to index till above it as well. So if I need to index above it for the consecutive above, then the number of rows might go out of bounds. So I think it should be rows plus 1 here. Same thing here, if I do the left side, it might index to -1, so I do columns plus 1. Okay, so consecutive above at this position is one more than the consecutive above at the previous row, same column. So for instance, like if I'm at this position, there's 2 ones above it, and because this is a 1, this means that now there's consecutively 3 ones above. So at this position there's going to be 3, which is 2 plus 1 from taking this one, which is one row less, same column. And then consecutive to the left is going to be row, at this position it's going to be one more than consecutive to the left at the same row, column minus 1. And I don't need to check for out of bounds indexing here because if the row is like 0, or if the column's 0, then it's going to go column -1, or column -1 is going to wrap around to the last column, which is a dummy column. And then and then I can say here, so I see, yeah, so consecutively, so if it's a consecutive, like 2 above this thing and 2 to the left of this thing, and also the biggest sub of the thing to the top left is 2 as well, then this thing can be 2. So like the square size that you can form here is going to be 1 plus the minimum of what is consecutively above this position, so it'd be row -1. Okay. Looks like I'm using the same value here. Wonder if I can, oh, whatever. Consecutively to the left, row column -1, and also the biggest sub at the row -1, column -1. And then the biggest sub at this row column. I guess I could have done this before. No, is the square, whatever that calculation is. So if like there's 2 above here and 2 to the left here, and the biggest square here is 2 by 2, then this is going to be 1 more than that, so that's going to be 3. But if like there's only like 1 consecutively here and 3 consecutively here, and there's a 4 by 4 here, then it caps out to be 1. And the answer is going to be incremented by whatever that biggest square is. Consecutive above, misspelled that. Unfortunate. Didn't even work for this case. Alright, let's go ahead and just do a very simple case. Should be 2. So there's just 2 ones that are isolated, so it should have an answer of 2. Okay. Let's go ahead and add a wall. Just go ahead and make this into a single 2 by 2. So the answer here should be 5. Okay, so this is 4. Why would this end up being 4? Alright, let me go ahead and just double check here. That's really weird. Oh, oops. The biggest thing here is 1, 1, 1, 1. This should end up being a 2 by 2 here. These are the top. This is the top of it, and this is the left of it. This should have done. So this should have been consecutively above it was 1. Consecutively. Alright, let's go ahead and just print out the other stuff. So it should be consecutively above is incorrect. And also consecutively left is incorrect. Consecutively above. So at 0, 0, consecutive above should be 1. Oh, whoops, moved the wrong one. Yeah, it should be 1. Consecutive above, position 0, 0, position 0, negative 1, 0. Oh gosh, it's not plus equals, it's supposed to be 1 plus. It's supposed to be incrementing. Wow. Pretty bad, pretty bad. I guess I got confused between the plus equals operator and the plus plus kind of operation. Is this fast enough? Maybe. Okay. Kinda slow. For every position, take the value at the position consecutive above. Yes. I wonder if you can just skip positions. Like certain positions can be skipped if you know that it's not gonna be able to do anything. So if you have a 0 at a certain position, then you know you can skip. You know you can only have 1 at any position next to it. I have 1 at position next to it. So I could do value 0, skip it. So here I have value 1. Then what? Then I can increase. I think maybe the slowest operation is this thing right here. Or it could be actually this thing right here, creating the matrix. Creating the matrix. I wonder. So if you have a position here, if you are at the bottom right of a square, you're at the bottom right of a square, so extend this thing, extend. So consecutively some number, consecutively 2, 1, 2, 1, 2, 2 above, 2 to left, then you make that into a 3, or you make this into a 2, and then what? Here it's a 2, but then this is consecutively left, consecutively above, and the biggest sub. So 2 by 2, extend it 1 to the left. 1, 1, 1, 1. So this is going to be 2 by 2. Now it's a 2 by 2. So if I know it's a 2 by 2, how do I extend everything on the right side of it? So I know it's a 2 by 3. Then I know it's a 1 by 3. Consecutively left. Increment the consecutive streaks. This is pretty fast. That's probably pretty fast. And then this thing. Seems a little slow. Squares, one more. Squares, one more. It's a 2 by 2. You have a number. A number consecutive to the left. So if you know that your number is 0 here, then it doesn't really matter. If you know that particular number is 0, then what? Then we go to the next number. We go to next number, which is 1. You know this is 2, and this is 2, and this is 2. And this becomes 3. Where this 2 represents a subsquare of 2. This 2 represents a consecutive upwards 2. Minimum of above. Okay. This optimization is whatever. I'm gonna call it a day. So summary here. This is going to be this is n squared, I think, or n squared is basically the size of the matrix, or m by n. I mean, I think that's as fast as it goes anyways. Like you have to check every element. Summary. The logic that determines if a position forms a subsquare of, let's say, a k by k subsquare of 1's is contingent on a subsquare of 1's, that is k minus 1 by k minus 1 to the top left of it, and consecutive ones, consecutive k minus 1 ones of and to the left of that position. The logic determines if a position forms, I'll note here, this is the bottom right of a k by k subsquare. So if those things are tracked in separate 2D matrices and updated appropriately, as you iterate over all positions, then it can be determined at each position what is the biggest subsquare of ones that can be formed. The answer is incremented by the size, the k size of that subsquare. So if you're at a particular position and you see that it can form a 3x3, then there's 3 subsquares that can be formed there, like the 1x1, a 2x2, and a 3x3. So you just do that for every position. And yeah, just create your 2D matrices. Update your consecutive stuff. See if there's a subsquare to the top left, the size of it, versus the size of the consecutive is the minimum of everything there. And then time complexity is going to be O of m by n as it iterates over each subsquare to perform logic. That is constant work. And then space complexity, this is going to be O of m by n to track the consecutive streaks, consecutive aboves and lefts, and biggest subsquare at certain positions.